Have you ever wondered how scientists determine the position of an element in the periodic table? Well, the secret lies in the electron configuration of that element. Today, we'll unravel this process step by step, and by the end of this video, you'll have a solid understanding of how to find the position of an element in the periodic table using its electron configuration. The first step in this process involves understanding the structure of an atom. An atom consists of a nucleus surrounded by orbiting electrons. These electrons reside in specific energy levels, also known as shells. The closer a shell is to the nucleus, the lower its energy level, and vice versa. Each shell can hold a certain number of electrons, and this capacity increases with the shell's energy level. Next, you need to understand the concept of electron configuration. Electron configuration is the distribution of electrons of an atom or molecule in atomic or molecular orbitals. It tells us how electrons are arranged in various energy levels around the nucleus of an atom. The electron configuration can be represented using the principal quantum number, n, which denotes the energy level, and the subshell label, s, p, d, or f, which denotes the shape of the orbital. Now let's move on to the periodic table. The periodic table is divided into periods and groups. Periods run horizontally from left to right, and groups run vertically from top to bottom. The period number of an element corresponds to the highest energy level that is occupied by electrons. The group number, on the other hand, can be used to determine the number of electrons in the outermost energy level, also known as the valence electrons. So how do we find the position of an element using its electron configuration? For example, consider the electron configuration 1s22 s22 p63 s23 p64 s1. This configuration belongs to potassium. The highest energy level here is 4, which means potassium is in the fourth period of the periodic table. The number of electrons in the outermost energy level is 1, so potassium is in the first group of the periodic table. Output. To wrap things up, the position of an element in the periodic table can be determined through its electron configuration. By understanding the structure of an atom and the concept of electron configuration, you can easily find an element's period and group number in the periodic table. Remember, the period number corresponds to the highest energy level, and the group number can be derived from the number of electrons in the outermost energy level. So the next time you're looking at the periodic table, you'll know exactly how each element found its place. And there you have it, a step-by-step guide to finding the position of an element in the periodic table through electron configuration. With this knowledge, the periodic table will no longer be a mysterious chart, but a map that you can navigate with ease.